All right, number 13 here, we got a related rates problem. We got students are traveling in two cars to a football game 135 miles away. The first car leaves on time and travels at 45 miles an hour. The second car starts 30 minutes later and travels at an average speed of 55 miles per hour. How long will it take for the cars to catch up? So to visualize that, all right, we got the first car that's leaving and it travels at a certain speed. All right, the other car leaves later, but it travels at a faster speed. We want to know when they'll catch up. So in other words, we want to know when their distances will be the same. All right. Now, once we figure out the time that they'll catch up, we can figure out the distance that the cars have traveled and see if it's been more or less than 135 miles. If it's more, then that means the first car got there before they caught up to each other. If it's less, if they catch up at a distance that's less than 135 miles, then that means that the two cars were past each other before they got to the game. So we'll make a little table here. We'll go distance, rate, and time. And you don't have to do it this way. This is just a way that I've kind of found that works in many, many scenarios. But don't feel like you have to do everything the same way that I do it. So we got the slower car and the faster car. But the slower car leaves first. So I'm going to let T be the time from when the slow car leaves. So if I let T be the slow car's time, that means T equals 0 is when the slow car starts. Because you don't have to do it this way. You can make this be T and add a half an hour to that. But in that, because this has been traveling for a half an hour longer because it left 30 minutes earlier. But then T equals 0 would be when the faster car starts. So you just have to keep that in mind. You want to make sure you interpret this correctly. So I'm going to go T minus 1/2 here. And be careful, it should be 1/2 because my time is in hours. And I want to make my time in hours because I'm given rates in miles per hour. So if the rate is in blank over hours, the time should be in hours. And the distance is in miles, so the rate should be in miles too. So the rate's in miles per hour. So the rates are, so the slower car is going 45 miles an hour, and the faster car is going 55 miles an hour. And we don't know the distance of these cars, but we'll call them ds for the distance of the slower car and df for the distance of the faster car. So we want to know when their distances will be equal, because when their distances are equal, that means they are passing each other. They've traveled the same distance, they started from the same spot. So now I'm going to solve the following equation. I want to know when the distance of the slow car equals the distance of the faster car. So I want to know when 45t is equal to 55 times t minus 1/2. So you could solve that pretty easily because it's a linear equation. But just to remind you how to use a calculator to solve equations, especially ones that are more complicated, you're going to go to a calculator, you're going to go menu, algebra, solve. And you're going to type in the equation 45t equals 55 times t minus 1/2. And we're going to do comma t because we're solving for t. And we get 11 over 4, which is 11 over 4, which as a decimal is 2.75. So we want to know if the cars will catch up to each other. So the first part of the question is how long will it take the second car to catch up to the first car? 2 hours and 45 minutes, because that's 0.75 an hour, from when the first car left. So will the second car catch up to the first car before the first car arrives to the game? Well, if the first car was traveling 45 miles an hour for 2.75 hours, that means that first car traveled 123 miles, which is not quite the distance that the football game was, 135 miles. So yes, the second car will catch up to the first car, about 12 miles, 11.25 miles away from the game. And so that's how you do it.